The apparatus below is used to show the diffusion of gases. Which pair of gases, X and Y, would cause no movement of water? If you look at the experimental setup, inside the porous pot, we're going to have the gas X, and outside the porous pot, we're going to have gas Y, okay, injected into this space here inside the beaker through the delivery tube here. So we're going to have gas Y here. The question is asking which pair of gases would cause no movement of water. Of course, for no movement of water, okay, which is in this manometer tube or U-tube, okay, the rate of diffusion of gas X and the rate of diffusion of gas Y into the pot must be equal. So that means gas Y and gas X must be equally dense. If they are equally dense, the pressure inside the porous pot is going to remain constant, and if the pressure inside here is going to remain constant, obviously that's not going to affect the water level at these two parts of the right hand limb or the left hand limb of the U-tube. So for the water to have no net movement, okay, gases X and Y should diffuse at the same rate. So when they need to diffuse at the same rate, what's important? For the same rate of diffusion, both gases X and Y should have the same density, which means they should have the same MR values. So what we need to do is to go to each and every one of the gases and let's work out the MR values, and let's look for which one of the option gives both the gas X and gas Y having the same MR values. So if you look at carbon monoxide, so there is one carbon and one oxygen, so that will be a 12 plus 16, adding up to 28. So the MR value for carbon monoxide is 28. However, for nitrogen dioxide, nitrogen is 14 and there is 2 oxygen, 2 times 16, and that should work out to 46. Carbon dioxide, carbon is 12 and there are 2 oxygen twice of 16. Twice of 16 will be a 32. 32 plus a 12 is going to give us 44. So the MR value for carbon dioxide is 44. And C2H6, 2 carbon, that means 2 times 12 plus 6 times 1, because each hydrogen is 1. So 2 times 12 is 24. 24 plus 6 is going to add up to 30. And of course in option B we can see that the MR values are not the same, okay, or not equal. And option A also, for the same reason, they are not equal. So when they are not equal, definitely there's going to be some net movement either up this way or on the right hand side up, okay. So option B is also not having the same value of the MR. So if you look at option C, C2, twice of 12, that's a 24 plus a 4, this is the gas called ethene. So that is having a relative molecular mass of 28. C2H6, just by looking at the formula itself, we can see there is a H4 and this one has got H6. So it's going to have 2 extra hydrogen, and 2 extra hydrogen is going to add 2 more to C2H4, and that's going to become an MR value of 30. So this gas is also not possible. Let's go on to nitrogen and check, okay, option D. Nitrogen, each nitrogen is 14, so 2 nitrogen has a total MR value of 28, whereas C2H4, okay, 2 carbon, 2 times 12, that's a 24 plus another 4, that gives us 28. So in option D we can see that nitrogen and ethene, both of them have a relative molecular mass of 28, and of course when both the gases are having the same MR value, they're going to be having the same density, which means that the rate of diffusion of gas Y into the porous pot and the gas X out of the porous pot is going to be in dynamic equilibrium, and when that happens, the pressure inside the porous pot is not going to change, which means obviously the water level on the manometer is not going to change either. So option D is the correct answer.